Okay, welcome. We seem to have two hemispheres over here with nobody in the middle, but that's okay. The screens are on the sides. So my name is Robert Mencarini. I'm an architect at Skidmore, Owings & Merrill, based out of the New York office. And today I'm going to be talking about detailing, but not just using the basic tools. We'll do that a little bit. We'll do some hands-on stuff, but also the process that has evolved over the last few years with working with various teams at SOM to detail mostly building enclosures is the example we'll look at, plus some other parts, and how working with Revit influences their process in good ways, mostly. And we'll go through some examples. So the first few minutes, I'm actually going to use some slides, and then for about 45 minutes or so, we'll go into Revit directly. We will get into working with drafting and overlay and drafting views. We'll talk about organizing strategies, which is sort of critical to detailing these large projects. And you can apply it to smaller projects, of course, if you're working on schools or hospitals and so forth. Especially the more people involved, the better. So we'll talk a little bit about that. And then we'll get into actually embedding 2D information into the parts of 3D walls. Now, I'm actually going to do this a little bit in reverse. We're going to start off with additional resources. So when you're done here, you know some other places to get more information on detailing. There's some great material out there, and I'm going to share that with you first. And then for those of you that are modeling in Revit but drafting in CAD, we'll talk about strategies for transitioning from one to the other. And then we'll get into actually the detailing tools. It's a small set of tools, actually straightforward. We're not going to spend too much time on it, and you'll see why. But we'll talk a little bit more about how to use them and how to leverage them. Now, at SOM, we do all different types of projects, all different types of scale, all over the world. So there's rarely any two projects that are the same. But what is the same is the attention to detail. We really spend an enormous amount of energy and effort so the buildings perform and feel and look and wear in ways that we hope sets the industry standard. These are just a few examples of all different types of buildings. The upper left is a new project at the Air Force Academy, which SOM's had a 50-plus year history with. We originally designed the Air Force Academy and have done a number of projects there since then. All the way down to like the lower right, which is the New School University Center in Manhattan, copper-clad building with a very expressive exterior shell, all detailed, modeled and detailed in Revit. As well as a bunch of hospitals and a few other projects that where the team spent a lot of effort working on the details. Now, some of these teams did spend quite a bit working in CAD, and this is all part of the transition. You know, those projects take 2 or 3 years to complete. If we go to this slide, if we talk about Tower 1, commonly referred to as the Freedom Tower, it's been in progress for about 10 years now. It'll be completed in about a year or so. They've topped out on the steel, and most of the curtain wall is up. But also, if you look to the right of that, in the shadow of it, is Tower 7. That building was done years ago, finished about 6-7 years ago. And although the Tower 7 is all CAD, the two things that were learned on these two projects, and the people that worked on these projects worked on a few projects after this, and we'll use some of those as examples. Now, Tower 1 was the first really large project done in Revit. My colleagues, some of which are no longer at SOM, but James Van de Zandt led that effort. He really pushed what Revit could do and proved that it could do all of these things, and really set the standard for it. On Tower 7, which was a CAD project, the team that worked on that and their detailing of that really took what is basically a trapezoidal plan, a very simple plan, and detailed it very beautifully. It's a real shining gem in the city. And we'll look at some of the work that these two teams, after these projects, went on to do and how they did it. In particular, there's Zulig Tower in the Philippines. Again, a relatively simple project. Not a lot of, it's basically a spec office building. Most of the energy went into the shell, which is not just aesthetics, but also performance, high performance building, but a lot of detailing. Now, this project was what we often refer to as a DD project, a design development project. And basically what that means is we design it and work on enough of the details to express design intent, and to a certain degree hand it off to local architects to help us complete the CDs. We do that about 50-60% of the projects that we do outside the United States. Now, on Zulig Tower, the team had about half the time they normally would have to do a project of this scale. And most of the team members came off of the Tower 1 project, where they really learned how to use Revit for modeling, but not so much for detailing at that point. Tower 1 this is about 7 years ago. Zulig Tower was about 3-4 years ago. And the team decided, and these were mostly designers, that they weren't going to use the traditional, let's design in Rhino and model in Revit and then detail in CAD. They knew they didn't have the time to do all that, especially going back and forth between the parts. So they set out in the very beginning to actually design it in Revit, render in Revit, and we use rendering as a design tool throughout the project, and then create a set of documents that highly details and explains the design intent. So just one simple example of one sheet out of a set of about 300 sheets. And they leveraged the model, and things that they did to detail it necessarily weren't the typical 2D drafted views, and which we'll see a bunch of those later in other projects, but they leveraged a lot of the 3D views. They had hundreds of these 3D views, these partial cutaway views. And one thing they did do is they actually made sure all the materials had the proper material settings, because then they could easily just tag the materials. And materials in these projects are very important. They're usually high quality materials, and they often change to certain degrees back and forth. And it's very easy to change the materials, and the tags automatically update. So they just leveraged the model to do all these things and created an amazing set of documents. And we call them DD documents, but they're really sort of about 30% construction documents to properly communicate the design intent to the local architects. Now, before we get into actually doing some stuff in Revit, I just want to get a sense of who's in the room here. I know there's about 200 people here, and so I just want to know where everyone's coming from. So if you're an architect or interior designer, why don't you raise your hand? Okay, how about engineers? Any engineers in here? Okay, we have a few, okay. And how about BIM, CAD, or digital manager, digital design manager? Okay, so people are responsible for like sort of mentoring other people to do this kind of stuff. Who's new to using Revit? Okay, that's great. About 20%, 15%? Okay. So who's using Revit to do sort of everything but detailing, which means like you're probably detailing in CAD a lot? Okay, every year that number comes down, so that's definitely progress. Okay, good. Okay, so this is where we're starting reverse. Usually in most presentations, we end with this stuff, where to find additional resources, but I want to point some things out that we use all the time at SOM to help our teams do their best. So the first is working with these guys. CASE, we work with them basically on a weekly basis. They're almost an extension of our digital design group, and they have a lot of knowledge. And one of the things I really want to point out, and sort of keep it on the detailing subject here, on their website they have an apps page, and on their apps page they have developed many plugins for Revit. I think most of them are free, some there's a charge for. There's a great one that is for swapping out wrong line types. You'll see in the model I use, which I didn't clean up the line types, team members just constantly make new line styles. They don't know what's going on, and you get this long list that just slows everyone down in detailing. And I was talking to these guys, and they said, yeah, we could do something about that. And they went and created this little app that allows you to do something Revit should do natively, but it doesn't, which is allow you to pick the wrong line type and swap it out for the right one. And then we've done some other things. We've actually built that into a mechanism that can help us do that automatically, so we don't have to do it manually per model. Also in design, with CASE, they have their sister site, Design Reform, where there's lots of videos, just-in-time training videos. A few things there on detailing. It's mostly on other things. But this whole idea of just-in-time training is actually really important. Many of you might go back next week and utilize some of this stuff, but what often happens is you won't utilize it for a few months or 6 months, or maybe it's, your colleague needs to know some of this information. In addition to watching AU online and repeating these videos, there's other resources that I encourage you to look at, and Case has many sort of just-in-time 5-10 minute videos that are really helpful. Paul Aubin's book. Is Paul in the room? I know he's here this week. I don't see him. Okay. We use these books a lot. There's a few books our team members use. Paul's work is great. There is sort of step-by-step, so I highly recommend if you're maybe a colleague needs this information, get a hold of one of his books, and they can sort of, in a few hours, go through this stuff on their own in addition. Paul also has this information on lynda.com. It is a pay-for-service, but they're actually great videos all through all sorts of Revit, and highly recommend those. The detailing one is very good as well. And, of course, many of you know these two books. James, Phil, and Eddie. I know Phil's here. I haven't seen Eddie too much lately, but I'd like to point out these two. We use them all the time in the studios. People are often looking for just how to do this and how to do that. And again, the just-in-time training is really critical. And at SOM, we have a BIM wiki. We're on that. We have all these training resources where we list out all sorts of things, the ECAD learning and so forth. And we list out about 10 different ways of getting the information they need when they need it, because rarely can they spend a week doing training and then use it. They'll just remember it after a few months. So having all of these different types of resources, plus videos on YouTube and so forth, are really a great resource to figuring out what's going on. But I also like to point out something else about these two books. On the right, the mastering book, it's a project by MBBJ, a beautiful project. On the left is an SOM project, and what's truly great about this is this team, which is SOM London, this was their very first Revit project. They had done a little bit, a few of them have done a little bit before, but not only did they decide to do it in Revit, it's a project in Geneva, that they did 100% in Revit. The CDs are really beautiful, the details, and they really sort of capture the idea of leveraging the model. My colleague Bob Urey, who's in the audience here, he spent about a week or so with them going through mostly modeling type things. And in terms of detailing, the talk I'm going to give today, about 45 minutes, is really all we did with the detailing. And I'll show you some of those details in a few minutes. And they were quite excited when James and Eddie and Phil chose it for the cover of their book. So this is just sort of one of the examples. And again, this isn't a 2D drafted detail, but this is utilizing the graphics power of Revit. These are views that were created, a few detail items put in here and so forth, and it really communicates the essence of this project very quickly. And they leverage the model in many ways like this throughout the CDs to communicate the design intent. It's not just simple plans and simple elevations and so forth. Let me just pop out of a PowerPoint for a second.
This PowerPoint presentation is available on the site?
Yes. Yep. I uploaded it last night. This is one of the drawings in the CDs. They actually had it printed in color so the contractors could see it. Contractors also giving PDFs and so forth. But just an example of detailing building enclosure and leveraging the power of Revit, where they actually color-coded the different types of panels. So not only is it tagged and so forth, which is one way of communicating what happens. You sort of look at the tag number and go look at that panel schedule, and you figure out what's what. They actually color-coded it. It's a pretty complicated enclosure, and it really not only helps with quality assurance and knowing that they've actually modeled the right panels in the right locations, but they can very easily communicate this kind of information. And look down through the text on the bottom, just simple legends, things we do all the time, text and arrows and graphics and so forth to communicate that. Let's zoom in on one of these here. And again, just typical type details, but again, they're leveraging the model. They're using the 3 stuff, just a section box and a little part of the view, annotating it, freezing that view, and putting it on their CDs. So going from traditional page after page after page of 2D only sections and plan details, you can actually achieve more and communicate more with leveraging Revit. Now, we're not going to dig into the CDs and the model on this project. We'll use something similar. But this is just an example of a combination of live section through the model, annotations, dimensions, and so forth, some detail lines to embellish the detail, and also detail components overlaid on top of it. Very common, very easy to do. And we'll talk about some of the tools that help you achieve that. Now, we're actually going to model something not quite this detailed, but something similar. So, I mean, many of us on our drawings will have dozens or hundreds of these types of details. Often we'll have a library. Frequently, if you're just getting into detailing in Revit, that library is in CAD. At SOM, that was the case about 4 or 5 years ago when my colleagues decided, okay, let's take all of these, I don't know, a couple thousand CAD details, which were highly organized and searchable and so forth. Let's convert them to Revit, so the Revit drafting views. And these are the type of things that you're actually not going to model. You're going to put on a drafting view where there's no relation to the model. But it's the kind of stuff that goes on to every set of construction documents that you have to be able to clearly communicate. This type of stuff too, just typical elevations, and whether it's door and door frames and so forth. So, before we get into Revit, let's just talk a little bit about the general idea behind the detailing tools. What I didn't mention is before I was at SOM, I had my own consulting business. I consulted with a number of architecture firms, mostly in New York and the Northeast and so forth. Before that, I spent 7 years at first Revit Technologies Corporation and then Autodesk after we sold it to Autodesk. And from the very beginning, I was always a champion of the detailing tools. And it was, in the very beginning, you couldn't detail at all. And that was clearly an issue. Our clients were asking for it. And we went through and we designed a number of tools. It was sort of a quick thing that we did. And over the years, more of the tools that were on that original list have been added, and then some other things, and to give us a full suite of detailing tools. But basically, detailing in Revit is really not all that different from detailing in traditional CAD, or even hand drafting, if any of you have ever hand drafted prior to CAD, which would be about 15 or 20 years ago. In Revit, one of the advantages is that you actually can base the detail on a live view, either plan detail or section detail. And depending on what you're doing, the detail started for you, and at 10%, 20%, whatever it is. And we'll talk a little bit about that. Essentially, these are the detailing tools in Revit. There's really only a handful. There's about 5 things: detail lines, detail components, repeating details, detail groups, and filled regions. There's also a revision cloud and installation, sort of one-trick ponies that are helpful, but not a primary part of the detailing tools. All of this can be found on the Annotate tab, and I'll point this out when we actually start driving Revit. In addition to those basic tools to create the common 2D drafted information, you work with all of these parts as well: text, dimensions, move, copy, array, trace. There's also some Revit-specific tools: line work, show and remove hidden lines, edit, cut, profile, and so forth. So these are all tools that you work with as well. In addition to those tools, it's the views, the drawings that are really critical. And it's all the drawings you're working with already: plan, sections, elevations, call-outs of those views, and drafting views. And a drafting view, we'll use a bit here. Again, drafting view is like a blank sheet of paper. It's like a blank layer in CAD. No relation to the model. It just allows you to draft information, so all those typical details or maybe graphical information. And one thing I'll show you is how we use it on projects at SOM where they're often complex, many parts. We'll actually use them to communicate to the rest of the design team the organization of something, how something works in the model or in the project. And we use those a lot. Sometimes those end up on CDs. Kind of like a legend, like a door legend or something like that. Sometimes they're just for our internal use, but I'll show you how we use those. In addition to that, there's also the vector link details, vector and raster details. We often have large libraries of stuff. Even at SOM, it's still common. Someone will have done something, could have been a couple of years ago. It was in a CAD project. They might go to the SOM library for stuff, but often they want a detail that was in a prior project. It's CAD. and we have a whole process for how to use that. Don't explode it in your real project model. Explode it somewhere else in a temporary model, and then bring in the stuff you need. We'll talk a little bit more about that in a bit. Now, in terms of building enclosure, how things generally work at SOM is there are a number of specialists in each office who have made a career out of creating highly expressive, high-performance building shells, building enclosures. And many of them, they've been doing this for 20, 25 years, and they lead a team who, maybe the senior people on the team have been doing this for 15 years, and where they spent their entire career using CAD and as well as hand-drafted. And this was an example of some details that one of the senior architects created were just very expressive. You really could take these details and just put them onto a drafting view and onto a sheet. They're CD quality. Although on a project they might sketch out hundreds of these little subtle variations to get the exact look and feel and performance out of the detail. Now, when we were talking about 12 or so years ago, creating the detailing tools in Revit, we spent a lot of time talking about what detailing actually was, and how architects and engineers actually use details to communicate information. And boiling it down, it's basically an abstraction of reality, right? If you take a buzzsaw and you cut through a building or a part of a building and you sort of look at it and maybe take a picture of it, what you see there, it looks nothing like what we actually model and draft, right? Everything we do is abstracted to a certain degree to communicate a design intent. Now, this isn't getting into the area where we might be modeling something so it can actually be fabricated directly from the model. That's slowly coming through. But for the foreseeable future, there's going to be a lot of this detailing, drafting, applying these drafted parts to live model parts, and it's an abstracted sort of way of communicating a design intent. Let's see. Let's go right into Revit. Let me sit down here. Now let me walk you through this model a little bit. Now, as we talk about these things, I'm going to talk about some parts that are a little bit beyond detailing, because when we're working on these projects, what's really critical is organizing the information and having the system set up the way that's really helpful. And one thing you'll notice me say, I'll either pick something on the screen or I will use keyboard shortcuts. And when I do that, when I use keyboard shortcuts, I'll explain which one I'm using. I'll say, DL for detail lines or MM for mirror and so forth. What I've learned that working with a lot of the architects who had been using CAD for many years, and their whole process of transitioning from that knowledge, sort of their workflow, which is highly ingrained in what they do, into Revit, is working in an environment where they're really familiar with. And fortunately, with Revit, keyboard shortcuts can actually mimic many of the things that are similar in CAD. So Revit may have sort of a predefined list of keyboard shortcut information, and the keyboard shortcut for keyboard shortcuts is KS. So I'll point out things like this throughout, things that are sort of on the edge of detailing, but are still very important to people's productivity. Things that I often add are for 3D views. We're often bringing up 3D views. By default, there's nothing here, and I'll just come in and actually let me remove this one. And I'll just type in 3D every time I sit down at a new computer or something like that and assign it. Close window, detail lines. There's the whole sort of commands you can add as keyboard shortcuts. And it's also possible actually to add more than one. For whatever reason, instead of 3D, you want to type in 2D, you can add more keyboard shortcuts for the same command. Sometimes people like to do that if they're transitioning from CAD to Revit. They want to mimic the keyboard keystrokes from CAD, and they can enter it just that way. Let's get rid of this one. Now, in this project, we're going to look at this corner right up in here. Now, this is about a tenth of the original project. It's a 1.8 million square foot project. It's about a 50-story office tower, corporate headquarters, in a very hot climate. And on the shell of this building, there is the enclosure wall, and then there are these solar fins, and they're angled to block out the hot afternoon sun, midday and afternoon sun. And let me open up a few other views so you can see this. Let's see. Let's open up architecture. Now, when we organize our models, it would be great if we could put architecture, structure, MEP, everything all in one model. But the scale of these projects, what we really normally need to do is actually break out the disciplines, which is pretty common among most projects, just for workflow purposes. But we often need to actually break out below grade and core, general architecture, sort of everything else, and then building enclosure. And that's how I have this one set up. I sort of ripped a lot of stuff out of this project and rebuilt it in a way to show you in class. So that's mostly what we have in the architecture model. I don't have interior partitions turned on. I don't have doors turned on and stuff like that. But there isn't a tremendous amount in a corporate office tower that's architecture. It's mostly floors, walls, and ceilings. Actually, let's look at structure first. How's that look up there? Can you guys see that? Yeah, that looks good, right? So it's this is a concrete building. This is with SOM structures. These two teams actually all happen to be in the same office, which helps a lot. And it's pretty highly detailed in terms of the concrete structure. And then the last part of the model is the enclosure model. Now, these are actually three models linked together: architecture, enclosure, and structure. The real project actually had a few more. I think there's about 6 altogether, below grade and some cores and stuff like that. Things I removed for this talk. So let me zoom in here a little bit more. And to get a sense of what's happening here, for the enclosure, there are basically 2 sets of Revit curtain walls. One set is the actual enclosure wall with the glass panels and the opaque panels. And down below, there's actually perforated panels where the parking garage is. And then there is a second set of curtain walls wrapped around the inner set, the enclosure wall. The second set are these solar fins. The solar fins are panels. They are Revit curtain wall panels in the shape of fins, these solar fins. There's no glass panel or anything like that. There are no mullions on this second set of walls. But the curtain wall mechanism allows us to very easily sort of hang all of these fins off of the building in the right location. We just basically create a curtain wall, grid it up. The grids, because the fins are 2 stories high, the grid for the fins is every other floor, and vertically it is the same width, 1,400 millimeters and 1,500 millimeters on the adjacent sides. So it's relatively easy to work with the curtain walls that do stuff like this, the Revit curtain wall, to hang these fins off of this. Now, in reality, these are all thousands of parts that one part connects to the other when it's built in the field. If I remember correctly, there are 6,000 glazed panels and 6,000 fins on this project. That actually may be per side. I can't quite remember. It's a pretty big building. There's a lot going on here. So what we'll talk about, we'll start off actually doing some real simple detailing for people who haven't used the detailing tools. We'll spend a few minutes doing that. And then we'll start digging down into how this project was detailed. And I'll explain some things that, why we did it and why that was valuable to this team at the time. I'm just closing those 3D views behind this model, although I ripped out 80% of it. It's still a couple hundred megabytes, so it's a little sluggish on this laptop. Just find the right views here. Okay. So earlier I was talking about the SOM detail library that we converted into Revit. Let me just quickly show you a few of those, and I'll show you how we organize that library. So I'm going to open up this, just one example. Now, these are all drafting views. Like I said earlier, drafting views are just a blank sheet of paper in Revit, no relation to the model. Well, over the 80-plus year history of SOM, we have created the standard library for many years. It was in our original custom CAD system we had built, and then in AutoCAD. And at some point, about 4 years ago, 5 years ago, we converted them all to Revit and maintained them in Revit. Now, these are all detail lines, detail components, filled regions, things I'll be drafting with in a few minutes. And there are a few thousand of these details in the SOM library. And let me just show you how that is organized a bit. I'm going to go to the Insert tab, and I'm going to go to Insert from File. Now, it's a great feature in Revit. Basically, what we're doing is going to another Revit project file, an RVT file. In this case, it only has drafted stuff in it, but it's all organized, and we're going to grab a few of those views and bring them into this project. Now, I just have a few of them here. I'm going to pick this one here. We organize it by CSI sections. I'm going to open this one up. So what it's doing behind the scenes is actually opening a Revit project. It doesn't show us the regular Revit open screen. It just shows us this Insert Views dialog box. And in here, we have all of the drafting views, all organized by numbers and so forth. And then all of those drafted views are placed onto a sheet view. So I'm just going to actually bring in just one of these and not the sheet. Now, a lot of this stuff is just detail components. Much of it is from the Autodesk library, all different pieces and parts. Let me, the line weight's a little messed up on the screen here. Some of it is highly detailed, and I'm not sure the threads in 3D are really needed on there, but they're in here. All the steel angles and so forth, the concrete anchors and so forth. And then they're just annotated. It's really nothing too complex. It's just the organization is more important to using this information than the simple drafting tools to create that. So let's go and actually create something real quick here. We could do the door frame. I have another one set up where it's a real simple wall partition. So often on many projects, you have these kind of things, or many sheets of the different wall types. We have sheets set up with all the typical standard SOM details, all of their coding, the UL listings, all of this graphical tabular schedules to explain all of the information. But frequently on a project, there's often need to edit it and take it and change it and so forth. That's what we're going to do here. We're actually going to mostly duplicate this one in another view and add a few more parts just to illustrate a few things happening. So I've actually set up this other view. This is a drafting view. And let's see, I'm going to close everything behind. Let's open these two up at the same time. And I'm going to tile these two windows by typing WT, window tile. And not just so we can see it, see what we're going to end up with, but so we can actually borrow some parts from one to the other so I can show some features here. So what I'm going to start with is actually these chipboard components here. These are detail components. They're built in the family editor, and we'll work a little bit in the family editor later on, but let me just open one up in the family editor. And it's in the family editor, it's simply filled regions and some lines. The filled region has a pattern, like a hatch pattern. It's line-based, so when we draw it, we can just pick the two endpoints. Real simple detail component. And we'll create another one, a curtain wall anchor, in a few minutes. So one nice feature in Revit, you can copy and paste between views. That's a little slow. You could go to where the detailing tools are, the Annotate tab, go to Detail Component, and search through this list for detail components. But the list is really cumbersome. I don't have too much in this file, but often there's hundreds of things on here. And this list is actually a little cumbersome to find what you're looking for. Definitely one area that Autodesk could improve. But one nice feature is the Create Similar tool. And what it allows you to do is actually use what you have on your drawing as a tool template or parts template. So I can just pick this, and I can, the create similar is this button right here, create similar. But what I'll do is use the keyboard shortcuts, just CS, and it puts me into the mode as if I'm creating a brand new component. And this works with all sorts of things in Revit, not just detail components. It could be walls, toilet fixtures, text, anything within Revit. But it just allows you to use the stuff on your screen as your tool palette. And I'll switch views, and let's come up here and just start drafting some of this information. Now, I could have used copy, but copy won't work between views. The CAD copy. I could use Windows copy, Control-C, and copy and paste, and that'll work fine. There's nothing wrong with that. But create similar is a nice way of doing it. So also, let's come back over here and grab this this track. Create similar. Switch views. The snapping, it sort of looks for what's around it. It'll snap to it. And we're going to change this detail just a little bit. I'll use create similar again. Model this stuff up. And say it needs a higher acoustic rating. We'll come in here and actually put a third layer of drywall on here. Now let's actually just draw a line here for a second. I'm using the detail line, DL. I'm using the default line that's here. Actually, let me change the line weights a bit so you can see this. Just to give me a bit of a reference here. Let me drop that down a bit. Remember I was talking about that case tool, that app they have for swapping out all the wrong line types? Well, this is what happens with teams when you have 10 or 12 people working on a project, and they're grabbing stuff from all over the place, and they can't find the line type they want, and they keep adding more and more and more line types over and over again. It drives us mad, and it slows everybody down because everyone they don't want to be able to quickly pick the line type they're looking for off the list and move on with what they're doing. Unfortunately, this is something that happens in Revit. You can see my handiwork here down the end. One day trying to clean this stuff up, trying to remove all the stuff they're not supposed to use. I kind of gave up after a while. They just kept creating more anyway, so I left them in there. So actually, let's change this to 3. Right here. Okay. So we're going to create a few more things. I'm going to type in DL for detail lines. Brings me up here. And these are the other tools right for detailing. We're going to pick one of the drawing tools, arc by 3 points. And this is, no, that's a little big. Let's try setting this to pen 1. Now, at SOM, we've tried a few different naming conventions for line styles. We've kind of settled on one similar to what we're doing here. It's not exactly the same, but generally the naming convention has the 3 attributes of the line style in the name, except for the specialty line types. Pen 1, the black for the color, and solid for the pattern. That works as well as a few other very similar ways of doing this. So I'm just come in here, draft that in, draft a couple more real quick, and just be done with this. Just some acoustic sealant at the bottom of the wall. Now I have all these pieces here. Instead of drafting them or copying them on the side, I'm just going to select them and mirror. I'm going to pick the mirror tool by drawing access. And let's see if I can snap to, where is this? Right there. Yep, I wasn't so careful there. Let me undo that. Now, as I do this, anybody have any questions? I know a lot of you have been using some of these tools, but there were a bunch of hands up for people who've never drafted at all in Revit. So if people are pretty familiar with this stuff, I won't spend too much time on these parts. I want to at least spend a couple of minutes. So very quickly, just building this up. I'll come over here. There's a nail to anchor this. I'm going to drop that in there. And the detail components, the 2D detail components, are relatively simple, but if you just notice, this is actually a parametric detail component. This anchor, whatever it is, real simple expression of an anchor, it has instance parameter for length. And if you go into the family editor, it's literally just these lines. Let me turn on the dimension so you can see this stuff. here. And it has a dimension that's labeled length, and it's an instance parameter. So creating stuff in the family editor, especially with these 2D detail components, and making them parametric is very powerful. It's a great feature of Revit. And we'll talk a little bit more about that when we get to the anchor. So let me close out of this. Okay, let's go back up to annotate, insulation. Width 100 millimeters is good. It's about 4 inches. Let's center right about here. Drop this in. I'm actually going to shift it over. And when I shift it over, so using the move tool, I'm going to use the arrow keys on the keyboard. Those are the nudge keys. And what those do is they move the item over. If I remember correctly, it's about 2 millimeters on screen. So it's actually related to how close in you're zoomed to your view. So if you zoom way out, it's moving 2 millimeters at that level. So the farther you're out, the more it's actually moving in real life units. And let's see, let's drop in this break line. Switch views, and let's just drop it right here. Now, the break line, all it is some line work and then a masking region behind it where it just masks out the other information behind it. In Revit, model geometry, if you're not in a drafting view, if you're in a regular view, is always in the back. Detail components, details, and so forth are in the middle, and annotations are on top. So things like arrows for text and text itself, level lines, structural grid lines, those are always on top. Here we can actually come in and grab the controls and adjust these parts. And let's actually grab this and move this down. So it just obscures the stuff that's behind. Now let's do the partial slab below. So what this is a filled region. It's like a hatch pattern in CAD. So I'll type in CS to create similar, switch views. Actually, I can't do that with that, can I? Let's do this. We'll go up here. Let's see, quit, edit that. You have to do it from here. Click on filled region. And the line style is set to invisible. We'll leave it at that for all the lines on the sides and the bottom. And let's see, let's start out over here somewhere. So as you draft things, Revit gives you all of the alignment lines, these green dashed lines, the temporary dimensions. Gives you a lot of feedback in terms of what's going on, so you can quickly draft stuff. Let's see here. No, they didn't do a simple rectangle. I'll mimic what they did. They sort of made it look like a broken section here. And it'll come up. Now, each segment of line can be a different line style. And let's see, I'll go up and I'll change it to maybe, what do I got going here? We'll do pen 5. And I'll finish it. I'm not sure that concrete's a good one. Let's see here. I'm going to use the match tool, MA, to match this filled region to the one that's over here. Very useful tool to coordinating the different types that you're working with. And we're going to quickly just annotate and draw some dimensions in here. Let me go down here and drop that in there, about 3/4 of an inch. And then we'll dimension this. And notice that on the original detail, they don't actually have the value because the width of the wall is really dependent on the different types of metal studs being used and in other settings. It could be a rated wall for whatever purpose, acoustics or fire rating, and that's the important part. The actual width is kind of dependent on other factors. Also, the height of the wall may get a bigger stud and so forth, and therefore require a different width. So we organize it this way. To do that, to actually not show the dimensional value but show this information, just double-click on the value, the dimensional value. Brings up this dialog box. And we'll do replace with text. Let's see, C, floor plans 4, and then we'll put the rest of it down below. Scheduled partition, okay. So just an easy way of having a dimension and using text instead of a dimensional value. So I'm not going to actually write out any text. Let me just copy it from the other view. I'll come in here and I'll do, let's see, for modify, paste current view. I guess I had a slightly different organization, but that's fine. I'll just use the drag tool. I'll move it up and move it over, because it happens to be the same information. And that's basically it. I purposely pick a real simple, relatively boring detail to show this stuff, because the detailing tools are actually no more than this. They're these 5 tools that you actually use over and over again. We have some tools at SOM where we actually analyze the models, and we look at what's happening. We look for the outliers and so forth. And one of the things we know by what's happening is the amount of work that goes into in terms of detailing at different stages. And we know when the teams start detailing, because we'll start seeing hundreds of thousands of detail lines. And we've noticed on some projects that are completely detailed, where there's 500 or 1,000 sheets of drawings, we'll literally see 300,000 or 500,000 detail lines. So we know where they are in the process by what they're using and how many detail components and so forth. So it's literally these same tools over and over again. Now, we'll not overdo this, and I just want to make sure anyone have any questions about this. Pretty straightforward stuff. Yeah, this one over here. Go ahead. Are we using keynoting? Is that what you asked? Some teams do. It's not a firm-wide thing. It kind of depends on the project and the client and the needs. What we'll do a little more frequently is use material tags and assembly tags, but not necessarily a real keynoting system that some firms use very consistently. Yeah, over here. Tags for the text. Yeah, we don't do it systematically. The question was, would we use tags that have these notes built into it? Some teams, after they've done a few projects, they'll start leveraging some of that, and it does help. We're doing it more with material tags and creating the schedules from that, but less so with the notes. But now that we have teams that are doing the detailing in Revit, they realize the power of Revit, that they don't have to create the same note over and over and over again and copy and paste between views. And I generally have a philosophy that I let them discover that a little bit. I'll sort of mention it earlier on, kind of put it in the back of their head, but I won't necessarily force it on them. And I'm actually going to talk a little bit about that process of not forcing doing it one way when we get into the detailing, because I'll show you one architect's first project. Question in the back there. Yeah. Yeah. How would we manage the effort where one team is using keynoting, but another project team is not, or within the same team? If you're using insert from file, if it has keynotes in it. Yeah, at the moment, all of those details in the SOM Revit library, those are all just text notes. There's no keynoting in there. There's no notes within tags or anything like that, no blocks or anything like that, which is not the way we're doing it. It could be more efficient, but we would have to, well, with the number of projects and the scale, we would have to actually automate some of that to make sure the right information in the tags and the note blocks and so forth are actually getting through and being consistent. It would be, if it was a smaller firm, 10, 20 people, and you're doing, a school or something like that, it's easier to manually manage that stuff. But when we have, a few dozen teams in each office, and they're working on, 40 projects a year, and things are moving, very fast, what we've discovered that we tackle that stuff and we figure out a way to automate it and automate the sort of the mundane organizing of that kind of stuff, because otherwise it's a real time sink on a project. Even to bring in a digital design specialist who may bounce around to different projects to actually do that, and just eats up a lot of fee. So We generally let the teams work the way that they're comfortable with, especially if some of them are new to the process, and sometimes we get mediocre results from that. And then sort of on the next project, we revisit it, and we have them figure out where they can do things more efficiently. And it's a lot easier bringing people along with that method and having them figure out their solutions, with enough guidance to understand there is something called note blocks and keynoting and so forth, and how that works. But to answer your specific question, at the moment we don't use it too much, so we're not having to manage some in keynoting and some not. Any other questions? Yeah, over here. Yeah, the question is, do we make a drafting view for every single detail? Mostly yes. All of the SOM standard or template details is what we call them. All of those are on their own drafting view, and each drafting view is placed on a sheet within that container file, which is just a read-only Revit RVT file, project file. So each one is on its own. And within projects, yeah, mostly. The drafting views each one is separate, and I'll show you a lot. There's in this particular project for just the building enclosure, there are a few hundred details, and they're all drafting views. You have a follow-up? Yeah, the question is how do we keep track and how do we name them? And it's something actually I'll get into and I'll show it to you because I had come up with a whole system. And working with these two senior detailers for the first time in Revit, they didn't like my system at all. They're like, you wasted your time. We have our own system. They sort of got it how they could sort of use their CAD system in Revit. It's a little bit different. They figured out a solution in Revit, and I'll show you what it is. And I saw another hand somewhere else. Is there one more question? No.
So all of these standards for component parts are set up according to the contract schedule or the class signal, or do you have a separate download for 16 components?
You mean the subparts within the drafting views?
Yeah. What do you draft for the drywall? Is drywall out in big long list that says casing,
No, and it should be, because sometimes teams want to actually get to the subparts. I'm sorry, the question was, the parts that are in those drafting views, are they available like in their own library so you can pick and choose them? And up until recently, no. So what we've been doing lately is after a project is completed, we go through, we mine the data in the project, we look for all sorts of best practices and best content, and we pull that out. And I'll show you one example that I did I pulled stuff out for just this project. It's about 30 or 40 parts, but the kit of parts, so you can use them again on the next project. And we're building mechanisms where you can actually organize that stuff a little bit more. I'm about 55 minutes into this, so let me move it along a little bit here. Let's quickly review. Let's see, let's close that, and don't close that one. I'll shut it down. Let's bring it back to building enclosure. And this laptop has about 2 gigabytes of RAM, maybe 4 gigabytes of RAM. Our workstations are a little faster, 24 gigs of RAM, so you can manage these models a little bit better. So this is a typical building enclosure sheet. In this project, there were about 200 of these altogether, each with 4 or 5, 6 details on them. And I'll just quickly walk you through what this looks like. Upper right here, we have the elevation, and we have a call out for the plan information. I'll zoom in a little bit more so you can see it, get a sense of what's going on. And what you're looking at is mostly modeled information with some 2D stuff added into here. We have the column is from the structural model, and there's a slab edge in there somewhere from that model. There's also a raised floor, so there is an edge from the raised floor within the architecture model. And then there's the rest of it is mostly in the building enclosure model. And let's see, this detail, let's see, it's cut right about here, which is about 15 feet below the top of this part of the building. And then there's another plan detail, which is from above the parapet. As I showed you on the Zulu Tower building, we often will include these 3D views right in our CDs nowadays, and that was a bit of a shift. And working with the detailers, where they do this all the time, they rarely ever did this, and because it was a lot of work to hand draft these kind of 3D views. But nowadays, they've adopted it. They've sort of reworked these sheets. They've been using the sort of the layout of these sheets for decades. To have another view on it, actually took a fair amount of conversation and figuring out how and where it was going to go and what other stuff was going to move over and get less space. And not an easy thing to adopt a little change like that, believe it or not. And then there's two sections through the wall. This one here is this one here, where it's cutting through the you can see the fin at the top of the building. And let's see, let's activate this view, and we'll drill down. Let me do this one here. Now, this is a drafting view. Most of the information here are drafted lines. Let me just select everything and show you, and I'll explain why we did it this way. Let's see. So to give you a sense, a lot of the stuff is just plain drafted lines on a drafting view, no relation to the model. What we've kind of realized that when we're working with the professional building enclosure detailers, the people who have been doing stuff for 10, 15 years in CAD, to sort of force them to build detail components and overlay on the model and with the graphics weren't exactly what they wanted. It was sort of too much for them to adopt the first time out, and even sort of the second project they're working on. So we sort of said, okay, they're highly efficient in drafting the information they want. They build these beautiful buildings. It really wasn't necessary to force them to actually leverage the model in every aspect. And we said it's okay. And we've noticed, over working with different detailers, it's a pretty common way of doing it because they're very comfortable with drafting a lot of information. They don't even blink at that. And once they understood the drafting tools in Revit, they realized they're not all that different, and where they are different, it was relatively a simple change. So we actually said, go ahead, draft a lot of this stuff. And little by little, we showed them actually how to leverage the model. So this particular detailer, she had done many beautiful buildings around the world, and it was her first Revit project, and she really wanted to use Revit. Everyone else on the team was using Revit, and so she was ready to take the challenge, but we just said we're not going to overdo it, right? We're going to pick some things where we'll leverage the model, and other things we'll just detail with detail lines. And she had hundreds of these drafting views, and she didn't blink at that. She had a few months to do this, and to force her to go and model stuff and think about things in that way, we knew that would sort of put the brakes on everything. So there's a lot of stuff that's just drafted in here, but it still came out great. And she did start realizing that working with detail groups was quite easy. So she made many detail groups and used them over and over again. This is the top of one of these solar fins. And in a few cases, we took these parts and we actually rebuilt them in the family editor as detail components. And she was brave enough to actually sit down and do a bunch of that. It was slower for her and making it parametric and so forth. And she's like, well, why do I need to do that? I've already have it drafted in Revit. I have it as a detail component in Revit. And I did the look on her face when I told her there's no way to take a detail component in Revit and create, a detail group in Revit, or even just lines, and automatically make a detail component. You can see the look on her face, just the blood just drained right out. She's like, what do you mean? In CAD, all I have to do is draft it, block it, block it out. I can use it on the next project. Definitely a handicap and limitation with Revit that you can't go from the project environment into the family editor and really reuse those pieces in a more efficient way, which is unfortunate. She sort of got the power of it, but then there's this limitation that it was getting in her way. So let's close a few of these here. Okay. Let's go and model the enclosure anchor. And I've set some of this stuff up, so I don't have to do every part. Actually, let me show you what one of these looks like first. Now, the example I'm going to use is a little similar to what we have right here. I'm going to use TL for thin lines to see it. The one I'm actually going to model is an embedded anchor. This is actually sits flush on the slab, but it's a similar part, and I'll show you how to do that. Because working with the detailers, introducing them to creating these things empowered them, and little by little they're creating their own. And we'll talk about the detail library and how we organize some of that stuff. So let me go and open this up. Okay, let me show you the complete one first. We're going to create this. We're in the family editor. This is the 2D detail component of family editor, so only 2D parts, no 3D parts. And let me open up my template that I made for this. Okay, so I just have some reference planes laid out here, and that's all. Now, to speed things up a little bit, I'm going to cheat. What I'm going to do is actually bring in an imported DWG. Actually, I took the previous view from here and actually exported it to DWG. Unfortunately, again, there's no way in Revit to show one detail component in another. Well, I guess I could do it here, but often we're actually bringing in things from manufacturers, which is in DWG. Although it's starting to change, we're getting more more Revit stuff from them. So let me just go to Insert, CAD, Library, Curtain Wall Anchor. I'll leave all these settings. And I already have the color set up magenta, just so we can see the difference in colors, and then use the Align tool just to align it. And this is mostly just a visual guide for me, nothing else. Oh, actually, let me use Move MV to move it down, put it where I want it. Because I didn't want to take the time to actually slowly draft all this stuff out. We're going to trace it real quick. Now, let's do this. I'm going to go to Create Lines, and we're going to change it to, since this is embedded, we're going to actually make all these parts dashed. I have all this stuff set up. And for part of this, we can just go around and trace. It's a little slow, so what I'm going to do is actually use the Pick tool, which will just do an automatic trace of the lines that are below. Now, especially all this stuff down here, which has many little parts. Let me just zoom out so you can see what it does. I'm just going to put the Modify tool, or the Trace tool, right over that, press Tab, highlight the whole thing, and then Pick. And it just traces right around it. And I'll do that again. And I don't think it did this one here, so let me just get to this directly. Now I'm using the Tab key to drill down because there's a few things on top of one another, so I press Tab and it selects the next thing in the pile of stuff. And I actually have an anchor bolt all set up for this. Let's see if I loaded it in here. So create, detail component. No, I don't have it in here. So what I'm going to do, I'm going to show you one of the container files where I keep this stuff. Curtain wall. Let me just open it up. And right after I'm done with this detail, I'll explain this container file a bit. I'll hold it to the end to see if we have time. So in this example of the container file, I've included the kit of parts that this is about halfway through this particular project, working with this architect, where teaching her how to create these parts in the family editor, and I would just collect them and put them into this holding file, and she would use it as her template. So what I'm going to do is actually, let me open up the view directly. I'm literally just going to copy and paste from this file, switch back to the other project. Oh, I didn't mean to do that, did I? Hold on a second. I have this somewhere else. No, I'm just gonna trace it. I guess I forgot that I didn't do that before. So I'm not gonna trace all of it to keep it quick. Okay, grab a few of these parts. Okay, I'm going to skip a few of these parts, and we're low on time. Just see here. Use CS. Actually, I'm going to simplify it even more. I won't take up too much time doing this. Yes, if I remember where I put it, sure. Oh, that's what I did. You're right. That's exactly what I should be doing. See? You got to keep me honest here. Actually, I can copy it from here, I think, right? Where am I? Here we go. That's what I did earlier. I had it from the other file. Okay, let me get rid of some of this stuff. Delete, delete, delete. Okay. And I'm going to use the move tool. Put it where I want it. And we'll leave it right there. So I'm going to quickly create some dimensions. Let's see, one here. Create one on this side. And then after I create these dimensions, we're actually going to make them parametric. So this is the overlapping part. Overlapping part. Okay. I'm going to select that dimension. I'm going to go to a few parameters I already have set up in here. Length 1. Depth 1. Length 2. And depth 2. You do that all right? Yeah. Now, whenever you create something in the family editor and you start adding these parts, it's a good idea to test them before you add too many. Otherwise, it's very easy to get lost, and it won't adjust the way you anticipate. So what I'm going to actually do is grab all the detail lines I created, snap them and lock them to the reference planes. Although some are right on top, they're not constrained. I want to constrain them. Let's see here. And let's see. I'm just going to move this one up. Let's see. I constrained that to the wrong one, so let's put in the right one. There we go. And it looks like I have to add a few lines here. And I need to add some invisible lines. And the way this particular piece is set up, this is embedded in concrete. So let's put this like that. Those are invisible lines. We see them here. They pre-highlight in the project, but they're not otherwise seen. Okay, let's adjust these. Snap and lock. Snap and lock it back to the reference plane. I think I got them all. Let's try this one. That one looks okay. Not that one. Okay, so I think I got them all, but it's a good idea to test. I'm going to come in here. Let's see. Let's move this off to the side. Let's make this smaller so we can see it. I know there's a few things that probably aren't constrained properly, but let's test it. That moved that way. That's not what I anticipated, so let's cancel that. Let's undo that. We want it to move to the left. So what I'm going to do is actually click on Defines Origin and even just pin it. So that reference plane is in that position. It'll stay there, and the whole thing will grow to the left instead of to the right. Let's see here. I'll try that again. 2 feet. Apply. Yep, that's better. Let's see, did it actually... Let's see what we got going here. The lines look like they all stuck to it. That's perfect. Let's go back 1 foot. Yep, that's good. Okay. And I'll just go through and I'll just test this stuff out. It's a somewhat tedious process, but it works. Now, let's see. These are left over from the first thing I was drafting, but one thing I do want is this anchor bolt to actually be near the end. So I'm actually going to dimension it, tie it to that reference plane, and we'll make it, I think, about 3 inches off the end should be good. And then we'll lock that dimension. So as this part moves, that should move with it. And I'll just quickly test out the depth and the width. We'll do 5 inches here, apply. That looks good. Go back to 3 inches, and then we'll do 5 inches here. Hit apply. That looks good. So, it's kind of stuff like that. Now, it took us, 5 or 6 minutes to do this? I kind of know what's going on when I show this off to somebody. Usually, we'll spend like 20 minutes trying stuff, and I'll have them create something similar. And they start learning the rules about how these constraints work and the power of it. But I rarely will start them off anything more complicated than this, right? It's 4 parameters, about 6 reference planes, and I just keep it at that level because otherwise it's too much to if I get too parametric with it, and they abandon it, they don't use it, so they end up creating, instead of a parametric one that has, you can adjust any size you want, they end up creating 20 of these, 20 files they have to maintain, which is clearly not the most efficient way of doing it. Now, let's, we can load into the project, but we're actually going to use it somewhere. We're going to use another one that's similar. How are we doing on time here? About 15 minutes left, so let me show you a couple more parts. Let's see here. We did all that. Okay. We're actually going to close out of the architecture model. We're going to open up the enclosure model. Let's see here. Close windows. Not going to save it. That'll take time. Let's see. Now we can actually just open the enclosure model and remove it from here. While I open this up, anybody have any questions? Okay, let me just say yes to all this stuff here. Open. Yeah, there's a question over here. When I'm showing the 3D detail, am I, what? How do they know where it's referenced? I mean, are they basing the... I think we have 3 related questions here. So in the plan view, that was a live plan view. It was a call out, and that was mostly modeled information. And then we could add other callouts and other views in there. There is a feature in Revit where if you detail something once, whether it's with a drafting view or with other modeled stuff, you can actually call that out over and over again. That's called reference other view. Every time you go to create a section, a callout or a plan detail or an elevation, I forget. There's an option on the option bar, reference other view, and you can pick that detail that you've already created and just reference it many times throughout your project. Is that your question? Did I? No, I went off the topic there. Yeah. Oh, you mean in the lower left corner of the drawing? No, we're not indicating that on any elevations or anything like that. We're mostly on the bigger elevations. We have a call out for the detailed elevation, and that sheet gets put together, and whoever's creating that sheet will go and create that 3D cutaway view and put it there. And it's their job to maintain the fact that that 3D view is for that part of the building. Yeah, that's a manual thing. Okay, so we're in the enclosure model now. And as I pointed out earlier, there are two sets of enclosure walls, or curtain walls, Revit curtain walls. One is to hold all the fins, and one is the enclosure wall, the panels. So here are the fins. We're actually talking about this part of the building right about here. I'll give you a sense of what these look like. Let me just isolate one of them. Let's see. We also need... Let me just spin it around so you get a look. Now these are just angled in plan and in section. And then if I open up just the enclosure wall, view of the enclosure wall, and zoom into that same area, you can see that as well. Now, since we only have about 10 or 12 minutes left, let me actually go through some of these panels and show you how we took some things like those anchor bolts or the curtain wall anchors and other parts and embedded them within the panels. To keep track of all the different panel types and actually to have as few panel family files as possible, we figured out how much we can put into one. We have about 60 different panel types on this building. Like I said, it's a big building, lots of different conditions, top, bottom, this side, that side, 1,400 millimeter, 1,500 millimeter, all sorts of different combinations. So if we did them all in separate family files, panel family files, and we had to edit something, we had to go through 40 different files. And that got really confusing when we then had duplicated for all the fins, where it has almost as many variables as well. So we figured out ways to embed as much stuff into one panel family and fin family as possible. So let me drill down here and select one of these here. I'm going to open this up in the family editor. Let me shade it so you can see it. Now, one thing we've learned over the years, we want the drawings and the elevations to look a certain way, and it has a lot to do with the intersection of the vertical and horizontal mullions. So on many projects, what we started doing is the vertical mullions are Revit mullions that we add to the curtain wall. The horizontal mullions we're almost always embedding in the panel family. And it just has to do with how we like those objects to look when we look at them in elevations and in the full-scale elevations as well as the details. It's just a technique that we use on many projects, but not necessarily all. It sort of depends on the project. So in this panel family, which is GP-1, we have a whole naming convention and so forth. It is used all over the building for the vision panel and the other parts throughout the building, top, bottom, and so forth. And what we've done is we have all sorts of parameters, mostly visibility parameters, yes, no parameters, so we can actually create different types within this one panel family. Now, we do have more than one panel family. I forget how many, 10 or 12, each with about this many. There's 8 or 9 types within here. And most of these have to do with visibility of parts that you see here. So like the solid panel in the back, that is set up to be visible. If I click on this little button here, for the spandrel panel, spandrel insulation panel, which, if I go back to the other dialog box, is associated with, when this one is checked, it's associated with, I think, this one here, right? So we sort of put all of these different parts into one panel family just to reduce the number of files we're working with. We would love to actually have it all in one super panel family, but it gets way too complicated for team members, so we organize it in logical chunks. And if I go and open up the, let's say, a section view, you can actually see in here that we actually embed up these 2D details that we were talking about. Now, this is a slightly different type of anchor. We've actually, let me open up this in the family editor. This is the flush-mounted one. It's rotated in the family editor, but it has the fire stopping. It has various parts. It has parts of the mullions and so forth. Now, the mullions that you see in model are relatively simple box shapes, and in here, this is a 2D detail component that we embed in the panel family. So when we cut a section through it and set the detail level appropriately, you can actually see that information. So we don't actually have to detail this over and over again, because it is something that appears on many times, and whenever something appears more than 3 or 4 times, definitely more efficient to create a detail component and use it throughout. Yeah, you have a question? Yep. Yeah, the question or the statement is it must be helpful to actually do it this way, so everyone knows where what part is and how it's organized. But we had to solve it. We had to communicate that because there were 3 people working, 4 building enclosure people working on just this part, and then other people were brought in at different times. And once in a while, someone's not on vacation, whatever. Other people need to join and need to quickly understand what's going on. And I'll finish up showing you how we organize that stuff. So let me close out of here. And you'll notice that there's a few different anchors. They're in different spots. Depending on the visibility, one will show up or another one doesn't, depending on which panel we're actually placing in the building. And actually, let me close out of here as well. So let me show you how we organize that stuff here. We have a drafting view called curtain wall type. And what we did is create a naming convention. And we just organized what we name everything, what we name the files, all of the subparts. Because without this organization, we're dealing with maybe 200 different files. No way to find anything and replace it and so forth. So one of those anchors and the fire stopping, one of those details, when it was updated by usually the senior designer working on that part of it, it was her responsibility to inform this team that she's actually updated that. The detail component would be updated, and they would have to make sure it gets pushed into all of the panels that need it. And fortunately, this team was just great at that. They just, once they had a process and we organized it this way, they would communicate, and within minutes, basically, they would just start pushing all of this stuff through. And right now, we have to do it manually. In the future, it'd be better we can automate it and press a button and update all of the details that use it. Because that detail component is not just used in the embedded panel, but it's also used in drafting views. It's also used in overlaid sections or plan details and so forth. It's the same part. But organization is really important. I'm not going to read through this stuff, but we basically organize what all the parts are called, even the subparts, the file names, and where they are, because it's the only way to actually drill down and know it. And it worked. When new team members were thrown on in that last month of the project, they were given an hour-long lecture, kind of like this, and how it's organized. They went through, they studied it, and they were immediately, within an hour or two, productive on the project. Versus when this stuff isn't organized, this could take a week to figure out, and it's just people get really frustrated when you don't organize it. Again, this is just a drafting view in Revit. It's embedded right in the building enclosure model. There's some graphics involved explaining what's going on. It's a very powerful tool, and it's just using the drafting tools to do it. On the other project, the one I showed from SOM London, that ended up on the cover of the book, they actually took a lot of that stuff and put it right into the CDs. They cleaned it up and made it a little more CD-like, but it's very important to communicate that kind of stuff throughout the project. We got 5 minutes left. I could show you the fins, but it's a very similar organization now. We sort of built the information into it and documented it. I'd be happy to show that, but let me see if there's any more questions. Yeah, there's a slide of that. Yeah. The question was, will the presentation have that? And the answer is yes. Any other questions? Yeah, one in the back there. Yeah, the question is, how do you show the embedded information when you're working on a curved building? And the part you didn't mention is the work planes, right? You sort of draft it in one work plane, and the section might be in a slightly different angle to that work plane. You don't see it. What you need to do, and actually on the London project where there were a lot of angles involved, they had to be very careful that the sections and the callouts were parallel to the work planes where the other information was. And they had a few problems where that changed throughout design, and they actually had to rip stuff out, the views and whatever, copy and paste stuff, and make sure that stuff was always parallel, because Revit doesn't handle that well. All the views to show stuff from one view to the next has to actually be parallel, otherwise you don't see it. Any other questions? Nope. Okay, let's just wrap up with one thing I want to share with you. Let's go back up into here. Let's do this. I mentioned working with the folks at Case in New York, and A few years ago, Bob Urey and I, Bob is sitting here in the front row, we were working with them, and it was right after the Revit API came out, and we wanted to know all of the different tools that were being created, the add-ons for Revit. We wanted to know what was out there. We asked them if they would produce a list for us, because they were working with firms all over the world, and I figured they would know. And in very typical case fashion, they're like, yeah, if we give you a list, it'll be obsolete the minute we give it to you. So why don't we crowdsource it? Why don't we create a little website out there, and we'll invite 100 people we know to share what they know, and we did that last year, about a year and a half ago. And about 100 or so people were semi-active on it, and they basically shared stuff, we shared stuff, and whatever. We quickly got a sense of what all the different Revit add-ons that were available out there. And this past year, we realized that this is a great thing, and we decided to actually make it a real thing. So this is something we've created. It's we're launching it this month, or January maybe, in the next month or so. And it is sort of a not-for-profit kind of thing, where it's a social media type site where like-minded architects, designers, engineers, people who are creating stuff, not just for Revit, all digital apps, whether it's large-scale programs, add-ons to Revit or Rhino, it's code scripts, code snippets, that kind of stuff. And it's a place for them to share this stuff, explain what they're using, what's working really well. If maybe they're creating their own stuff and they want to share it, and we're hosting this, and we're hoping that it can help sort of communicate all of the great stuff that's being added out there. And since I'm such a fan of detailing, I hope there's a lot of detailing stuff, including trying to organize all those detail styles that always happens in Revit files. So with that, thank you, and I hope AU 2012 is working great for you. Take care.